Could it be a succulent, pink, wiggling worm? No, it was actually this alligator snapping turtle's blood-engorged tongue appendage acting as a lure. It's far from the only animal doing tongue trickery. Fish attracted to prey-like ripples at the water's surface might find themselves in the jaws of water snakes who used their tongues to put those ripples there. Snowy egrets do the same thing, and puff adders lingually mimic insect movements to snag amphibians. Tongues are getting all kinds of busy across the animal kingdom for many different reasons. Some are used as murderous missiles in ambush attacks. Within the chameleon's mouth, a tongue muscle squeezes a series of concentric sheaths around a cartilaginous rod, storing elastic energy. As the muscle further contracts, the tongue tissues slip over the tip of the rod, releasing their stored energy and accelerating the tongue forward. With a suction cup-like tip and saliva 400 times thicker, and therefore much stickier than our own, the chameleon's tongue shoots out at almost 5 meters per second and ensnares its target. The rosette-nosed pygmy chameleon can shoot its tongue 2.5 times its body length at speeds equivalent to a car going from 0 to 96 kilometers per hour in 1/100th of a second. It might take the cake when it comes to the animal kingdom's fastest tongue, and the one that stretches the longest relative to body size, except the cake is obviously a bug. A giant palm salamander's spring-loaded tongue, meanwhile, packs its punch from 2 long muscles that stretch past its front legs. Once contracted, they compress the arms of the cartilaginous skeleton at the base of the salamander's tongue, which then launches out with the rest of its tongue tissues. From this elastic energy release, the salamander achieves more instantaneous power per kilogram of muscle than any vertebrate on record, affording it whip-quick captures. Certain amphibians have their tongues rooted to the front of their mouths. With the drop of its lower jaw, the northern leopard frog's tongue flips out. And because frog tongues are super soft, up to 10 times softer than our own, they stretch to cover a wide surface area. They're also covered in glands that secrete sticky saliva to maximize those areas of contact. Then, because the leopard frog's tongue is positioned so far forward, it can retract its eyes to help push the prey down its throat. Blue-tongued skinks, meanwhile, seem to display their extraordinary tongues defensively, dazing predators and robbing their aerial attacks of momentum. For other animals, it's all about lingual length. When red-bellied woodpeckers' extended barbed tongues aren't probing for protein-rich comestibles, they're wrapped around their skulls. And giant anteaters evoke the question, why have teeth or a mouth you can open any considerable amount when you could have a 60-centimeter-long tongue clad in backward-facing spines and adhesive saliva that catches up to 30,000 termites and ants a day? To which evolution answered, you actually have a really good point. Tube-lipped nectar bats' food sources are less animated, but still, to reach bellflower nectar, their tongues are 50% longer than their bodies, the longest relative to body size among mammals. Tongue textures also vary widely. Tiny structures called papillae cover tongues, facilitating touch and taste sensitivity, and more. Rainbow lorikeet papillae bloom into feathery projections that sop up nectar. And penguins press their backward-facing, centimeter-long spiny tongue and palate papillae together to secure their slippery catch and direct it into their gullet. Meanwhile, sandpapery feline papillae are thought to retain saliva during self-grooming, helping cats cool, detangle, and distribute scents. And, of course, some reptilian tongues reach a fork in their roads. Snakes spread their tongue tips apart near the ground and whip them up and down in the air, sending odor molecules back into their vomeronasal organs. Like having 2 ears, each tongue tip delivers a slightly different odor sampling from the environment, helping establish a more comprehensive stereo scent map. This way, snakes can determine where an odor cue is strongest and stay on the trails of prey and mates. And that is just a taste of the fascinating things you'll find when the animal kingdom opens wide and sticks its tongue out at you. Interestingly, genitalia also vary widely across the animal kingdom. Explore the biology of nature's nether regions with this video. Or find out why cats have vertical pupils while goats have rectangular ones with this video.